Suppose we have the position time curve being linear in this simple case, and a particle moves from x0 to x from time 0 to time t. Well, the slope of the tangent to this curve in this case is constant, and it's equal to the rise over the run. So going this way, we basically took the derivative, and the area under the rate curve, or the rate of change function, which is the velocity in this case, can be obtained by multiplying this slope by time to give the area under this curve. And that area gives the accumulation of change. So as you can see, if you multiply x minus x0 on t by t, the t's cancel and that gives you x minus x0, which is the accumulation of change from time 0 to time t. So the rate of change function can be positive or negative, and in this simple case it's positive, so the accumulated change is positive. And because in this case we have a simple linear function, we're able to evaluate the accumulation of change using simple geometry. But later on, when we want to find the area under a curve, we're going to apply different methods. And as we can see, the unit for the area under this region is equal to the unit of the rate of change, which in this case we're looking at velocity, so that will be in meters per second. And that's going to be multiplied by the unit of the independent variable. So in this case our independent variable is time. So if you multiply that by our time in seconds, the seconds cancel and you get the position in meters.